Hello everybody, this is Jeff Janess and welcome to our 6th lab exercise in projections and datums. In this lab exercise we're going to see how the coordinate system of a data set can affect how the select by location tool works. So we're often wanting to select the number of features that are within some distance of another feature. Maybe we want to select the number of beautiful sites within walking distance of a trail or a road or something. It kind of gives us a sense of where we can get to. Well, this is a real common thing in GIS, and it turns out that the coordinate system we use has a big impact on the number of features that are selected, or whether or not a feature is selected. So I'm going to show you how that works. I'm also going to show you a new feature in ArcGIS Pro where they are now offering the ability to select by geodesic distances, and this is always the most accurate. So this is a cool new ability in Pro, and we'll compare all of these. All right, so in this exercise we're going to be selecting this feature class survey points, and we're going to be doing them within a distance of this polygon here, and this is at the base of Mount Eldon, in case you're wondering. So we're going to start by zooming in roughly to this polygon with a little bit of buffer, because we're going to be selecting points within 500 meters of this polygon. And we're going to see what happens when we change the coordinate system of the points. And just to be clear, when we select by distance, ArcGIS Pro uses the coordinate system of the feature class that you are selecting from. So we're going to select the number of points within distance of the polygon. ArcGIS is going to use the coordinate system of the points. So what is that coordinate system? You remember we open up the layer properties, go to the source tab, hit spatial reference. These points are in UTM zone 12, projected from NAD 83. And so the distances are going to be calculated over that surface. All right. Okay, let's start by just doing the selection right on this feature class. It's the select by location. We're going to select from survey points. These are input features, are the things that are going to become selected after we run this function. We're going to use the within a distance relationship. We could actually use intersect plus a search distance. It would do exactly the same thing as within a distance. In either case, we're setting a search distance of 500 meters. We're selecting it based on the proximity to the Eldon Small Project polygon. And the selection type is going to be a new selection because this is the first thing we're doing with these points. All right, hit apply. Okay, we see, a little hard to see, but these points are selected within 500 meters. Going to see how many there are. And it's in the attribute table, and we see that we have 464 points selected. All right, so within the UTM Zone 12 coordinate system, there are 464 survey points within 500 meters of this polygon. Okay, now I want you to see the effect of the coordinate system. What does that do to the number of points that are selected? So we're going to project our survey points into these four other coordinate systems and reselect using that same distance and just see what happens. Now it's a lot easier to pick the coordinate system with these well-known IDs, so we got those in there to help make this a little easier. Now, before we project, we have to project into new feature classes. Before we do that, we need to clear the selection. Otherwise, the project tool will only project these selected features. So let's clear that out. That's this little button here. All right, the project tool is in the toolbox. Here it is. All right, I'm going to project the survey points into each of these four feature classes. In each case, I'm going to name it according to this suggested name, just to make things easier for me later. Okay, now I have my four new feature classes. We're just going to run the select by location tool on all of them simultaneously, and this is something that the tool does pretty well. And also, we're going to be filling out this table here as part of our homework. So I'll show you how to do that. But in order for you to be able to do this on your own, I'm going to do this at a distance of 1,000 meters instead of 500. You'll be doing it at 500 when you fill out the table. All right, so we're going to do select by location, map, select by location. We just drag all of these over into the tool. We only need that one a single time. We're going to do within a distance. I'm going to do it at 1,000 meters. And you know what? An easy way to check the number of features that get selected in each of these is to switch this sorting option to list by selection. When we run this tool, we'll just get the exact number appear right in the list here. All right, so it's set up to go. I'd hit apply. And there we go. And here we see that we range from 3,114 points selected in this one, all the way down to 229 points selected with the stereo. A tremendous difference, an order of magnitude and more difference between the number of points selected just based on the coordinate system that you choose. Within survey points in NAD 83, we have 884. So I would fill out this table. So I would fill out this table like this. All right, so the original feature class is 1005. That was in the UTM Zone 12 coordinate system. Within NAD 83, it's 884. Within the Albers coordinate system, it's 1012. Within the South Pole stereographic, it's only 229. And within this ARC System Zone 17, it's over 3,000. All right, so tremendous magnitude of differences. And for your homework, be thinking about why. Why would you get 3,000 here and 200 here? And for your own benefit, think about the implications this would have for your work. If you have to select the number of points within a distance, consider that the problems of choosing the wrong coordinate system. All right, anyway, the next part of the lab is to recalculate all of these using geodesic distances. So we did it within a distance. Let's try it again within a geodesic distance. Remember, this will calculate distances over the curved surface of the planet. So it'll go right back to the lat long values, calculated in the most accurate way possible. It is generally a much better choice, and this is a very new option that's available to us. So we should go with it when we can. And consider it should get away from all of these projected coordinate systems and therefore do away with all forms of distortion. So if we hit apply now, kick the geodesic distances, look at that, all of them came out to be the exact same value, and this should be the true, most accurate value possible. And that's the table that you would turn in with your homework. But remember, you'll be doing it within 500 meters and not 1,000, so you'll have lower numbers here. You might notice that the UTM Zone 12 really did a good job. It came extremely close to the geodesic distance value. So the UTM is really a good coordinate system to use for our work. All right, so another question for your homework is why would you choose geodesic over standard distance? And hopefully our demonstration right now has given you a good idea for that. All right, thanks so much.